Pretend as if we're working at an automobile factory. And we're going to be making some very simple cars. Our cars are going to be made out of frames, bumpers, and wheels. And these are going to be used to make a car. So for every one car, let's say that our coefficient here in front of cars is a 1. How many frames do we need?
1.
How many bumpers do we need?
2.
And wheels?
4.
All right, so we can treat these as if they are coefficients in a balanced chemical equation. And if we then had an example where we had 50 frames, and let's say we had 80 bumpers and 100 wheels, we'd like to know how many cars could we make? How many cars could we make with 50 frames, 80 bumpers, and 100 wheels? And that, by the way, will take us to our next Socrative app question. How many cars can we make from 50 frames, 80 bumpers, and 100 wheels? Talk with a neighbor if you need to. 5, 4, 3, 2, 1. The answer here is 25. 25 cars is the number we can make. Now, if we want to come back to that, we're now going to look at this using dimensional analysis. If we want to do this with dimensional analysis, we'll treat these numbers as if they are coefficients in a balanced chemical equation. If we want to do this one here, we'd say that for every one car we have one frame. And frames cancel out, leaving us with 50 cars. If we do the second one, for every one car we have 2 bumpers. Bumpers cancel out and leaves us with 40 cars. And if we have 100 wheels, for every one car we have 4 wheels. Wheels cancel and it gives us 25 cars. So why would we give an answer of 25 if we have 50, 40, and 25? The rest of them won't have wheels, exactly. Once we get up to 100 wheels, we run out of cars. So basically, what we do is we ignore these answers and we keep the answer of 25 cars. And again, it's because we run out of wheels, we don't want cars, or we can't have cars without wheels. So now in a chemistry context, here's how we would give these labels. This right here is referred to as the theoretical yield. And the 100 wheels right here, this would be referred to as the limiting reactant. And here's what these terms mean. Here's what these terms mean. A limiting reactant is the reactant that limits the amount of product that can be made. It's that simple. Limiting reactant is the reactant that limits the amount of product that can be made. And the theoretical yield is defined as the maximum amount of product we can make. It's the maximum amount of product we can make when all of the limiting reactant is converted into product. So again, it's the maximum amount of product we can make when all of the limiting reactant is converted into product. Now, anybody here work in a factory or have worked in a factory? Okay. What do you make in the factory?
Parts.
Okay. And so when you're in your factory making parts, does every part turn out perfect? Okay, and if they don't turn out perfect, what do you do with them?
Scrap them.
You scrap them. Right. So let's say that your product was cars you're trying to make. So if you scrap them, then the amount of cars you wind up making is going to be more or less than that amount. Less. You can never make more than that. So again, when we talk about this, is the maximum amount of product we can wind up making. So we then have another, if we're talking about making cars, what could happen there is maybe our frames are defective, or maybe our wheels are defective or something. Actually, we would not be in big trouble if our frames were defective, because we had plenty of leftover frames. Where we would be in trouble is if we had defective wheels in here. And if we had defective wheels, then we certainly couldn't turn out 25 cars. So then the next question looks something like this, and says if we follow up with this, if 23 cars are made from 50 frames, 80 bumpers, and 100 wheels, what is the percentage yield of cars? 5, 4, 3, 2, 1. Correct answer here is 92% yield. 92% yield. So now, if we want to wind up with a 92% yield, let's see how we'd go about doing that. First of all, if we calculate percentages in general, percentages are always calculated the same way. They're found by taking the part over the whole, and then what? Times 100. So if we're dealing with chemical reactions, or talking about percentage yields, we want to look at the part, which is going to be the actual yield. We want to divide that by the whole amount, which is going to be the theoretical yield. And then what we're going to do is we're going to take that result and multiply it by 100. So it's the same thing. It's the part over the whole times 100. So if you go back to the making of your parts back there in the factory again, you take your actual number of parts that you turned out, you divide it by the number that you could theoretically make, multiply that by 100, and that'd be your percentage yield. And having worked in the plastic factory for a while, I was the same thing. I got bonuses based on the number of good parts I turned out. If they weren't good parts, I had to scrap them, and then I didn't get the bonuses. And I don't know if yours worked the same way, but yeah. You know, we used to have all the good things back then. We got bonuses, though, if we turned out more parts. Now, in this case, if we want to get that percentage yield, what was the actual yield of cars here? 23 cars. What was the amount we could have theoretically made? Right. Then we take that result, multiply by 100, and we get 92%. We say that this is a 92% yield.